Hey everyone, how's it going? In this video, we're going to work on the kinematic equations and show how they can be derived. So let's recall from my speed versus velocity video, let's recall that my average velocity is equal to my change in position, my delta x, divided by my change in time. So my x final minus x initial divided by my time final minus my time initial. Now, let's say I have a graph right over here that is a graph of velocity versus time. And let's say my velocity at some time 1 is v initial. And let's say my velocity at some time 2 is my v final. And let's say that these velocities changed with this, with a line pretty much, so a constant change. Well, what did we say? We said that the change in velocity is actually acceleration. So if this change in velocity is constant, then we can say that acceleration is some constant, or our acceleration is not changing. Okay, if this is the case, if our acceleration is constant, then what we can say is that our v average is just equal to our v final plus v initial divided by 2. And this is thanks to, the acceleration being constant. So what we're going to do is we're going to plug this v average into this v average. So what's that going to give us? That's going to give us v final plus v initial over 2 is equal to delta x over delta t. All right, let's play around with this a little bit. We can say if I multiply both sides by delta t, I get delta x is equal to 1/2 vf plus vi delta t. And this is, in fact, our first kinematic equation. And what's useful about this equation is that we actually don't need to know a single thing about acceleration. So for a note here, I'll write no acceleration needed. So if we're given a problem where, we know our final velocity, our initial velocity, our change in time, or, any of these 4 variables, but we have no way of finding acceleration, that's okay. We don't need it. We can just use this equation. Okay, let's do another equation. So once again, recall that my average acceleration is equal to my change in velocity over change in time. Since my acceleration is constant, which is what we're assuming for these problems, if my acceleration is constant, so let's say this is a graph showing my graph of acceleration versus time, so this is acceleration in time, I can say that average acceleration is just equal to acceleration because it's not changing. So my average is going to be the same value as, what it is. So we're going to assume that. So instead of writing average acceleration, we're just going to write a is equal to delta v over delta t. Now, I can rewrite this again as saying v final minus v initial over delta t. And if I multiply both sides by delta t, what do I get? I get v final minus v initial is equal to a delta t. And then I can just add my v initial to both sides. That gives me v final is equal to v initial plus a delta t. So this kinematic equation is useful if we're asked to find our final velocity. If we know our initial velocity, our acceleration, and what time has passed. If you notice, what's missing from here is the position, so no position needed. So, if we're given a problem that tells us nothing about position, that's okay. We don't need to know it. Okay, so now let's say that we take our first equation and we multiply it by a modified form of our second equation. So our first equation is delta x equals 1/2 v1 plus, or vf plus vi delta t. And for the second equation, I'm going to say a is equal to vf minus vi over delta t. So I'm just taking the a from over here and this part. Okay, so what do we see happens? Well, if we multiply these, we have the delta t's cancel, and we end up with a delta x is equal to 1/2 v final minus v initial, v final plus v initial. Now, if you're familiar with some of the special quadratic formulas, or quadratic identities rather, you can say that this can be written as a delta x is equal to 1/2, we can say vf squared minus v initial squared. Now, we don't really like fractions, so we're going to multiply everything by 2. We get 2a delta x is equal to vf squared minus vi squared. And once again, we can bring vi to the other side, and we can say vf squared is equal to vi squared plus 2a delta x. And this will give us our third equation. And what do we notice is missing here? Well, there's no time needed. So no time needed. All right, great. Let's see. If we plug in equation 2 into equation 1, what are we going to get? Let's see. So equation 2 tells us that v final is equal to v initial plus a delta t. So we're going to plug that in for v final right over here. That is going to give us delta x is equal to 1/2 v initial plus v initial plus a delta t, all times delta t again, right? Okay, so what does this simplify to? We get delta x is equal to 1/2 2vi plus a delta t times a delta t. We get delta x is equal to 1/2 2vi delta t plus a delta t squared, or delta x is equal to vi delta t plus 1/2 a delta t squared. So this is another kinematic equation, and here we don't have a final velocity, so no need for final velocity. And you can imagine that if we were to instead take a look at equations 1 and 2 right over here, so what we did right now is we plugged in for v final right over here. But instead, what if we rearrange this and plug in for v initial so that our equation doesn't have v initial anymore, it just has v final? Well, using the same logic, we can end up with kind of a similar equation. It says delta x is equal to v delta t minus 1/2 at squared. So I'm not going to walk through the derivation of that, but know that it's extremely similar to how we got this kinematic equation. And right here, that should be v final. Right here, we don't need our initial velocity, so no need for v initial. Okay? Great, so let's see what kinematic equations we have. We have 1, 2, 3, 4, and 5. And if you notice, all of the equations have one thing missing, but they all have a different thing missing. So depending on what parameters we're given in the problem and what we're asked to find, we're just going to pull out one of these equations and we're going to use it to solve the problem. So I hope this video helped. If you have any questions, let me know. And as always, happy studying. If you found this video helpful, please take a second to hit the like button or comment down below. If anything in this video was unclear, or if you had a question about any other topic, please don't hesitate to comment it or send it to me in a message and I'll do my best to answer it for you. Thanks for your support and happy studying.